Let's all welcome Ms. Lourdes Carson.
Good evening. Welcome to today's focal point of our presentation regarding stem cells last week. This is your host, Lourdes Garcia. We are live direct from Glendale, California via the FilipinoCentral.com. Yesterday, we had the privilege of interviewing some people regarding their opinions about stem cells. Here is the clip about those interviews.
In the world, in sciences, in medicine, and especially there is always a good side and a downside when it comes to inventions. So then, but if the stem cell is the answer to the like chronic diseases and even the advanced world now, and the disease, there's not really like a cure, and if the stem cell is the answer to cure the people with all of the diseases that advanced medicine cannot, like in the present days, so why not? There will come, the world is getting modernized and advanced, and so there will come a time, I know, like in the future, that the people will just go to like stem cells for this. They have these diseases and they have this area that the stem cell can cure. Why not? For me, like, I think it's good, like for me in the future. In the world, in sciences, in medicine, and especially there is always a good side and
My opinion about stem cells, I know it's a new discovery about health science, right? And I'm not sure about if I don't know much about disadvantage and advantage of this new product, but I guess it's out in the market, so people they will talk about it actually. So I know I've heard a couple of people already that already used it. If it's good for them and it suits them, then why not? I mean, that's all I can say. I have not tried it yet, but there's no hurt in trying, right? That's all. Thanks.
Okay. Yung stem cell program, advantage yan dahil inapprove yan ng most of Californians, voters sa California. Dahil mayroong medical advantage yan na especially ngayon na approve na. Tapos ang implication yan talaga yung replacement of our human organs, di ba? Tapos ang nangyari niyan, but yung mga iba naman, yung mga theologian, when it comes to ethics science, bawal sa kanila yan dahil inisip nila hindi maganda dahil pinapalitan daw yung God na yun ang sabi nila. Pero sa akin mas maganda ang stem cell dahil ma-replace natin yung mga organ natin na we could live longer, parang yan lang ang opinion ko dito sa stem cell program.
Well, actually, I don't have any idea about stem cells, but I heard that it's been the doctors, technology, science, everybody's been talking about it. And for me, if somebody, like let's say somebody is sick and you're curious about it, probably my advice is you should have to have lots of research about it, ask more doctors, read some more studies about it, so you'll be aware, and you're not going to regret it if you try it and it didn't work for you. So there.
I play a lot of sports, and stem cells, I believe, helps a lot, and it gives me, it cures my injury, and I believe this helps the society to realize that the stem cells will be good for everyone. So I encourage everyone to please check this out, and this is good for everybody. Thank you.
Yeah, I think it's an advantage ang stem cell, and it promotes good collagen pag ginawa yung PRP. Yeah, I think it's an advantage.
Stem cell, hindi ba delikado yun? Parang nakakatakot yata.
So exactly what are stem cells? Today, most biologists agree that stem cells are defined by two key characteristics. It's self-renewal and self-differentiation. Stem cells have the capability of self-renewing, and they have the capability of differentiation, and that's how we are able to know that they are able to, in their capability, divide and renew themselves over a long period of time. So for differentiation, the stem cells are unspecialized, meaning when they divide, each new cell has the potential to either remain a stem cell or to differentiate into a specialized cell. So that's how we know that stem cells are specialized into something, or they're just a regular stem cells. And so why do we study stem cells? Studying stem cells can help us understand the complex processes involved in cell division and differentiation. Many debilitating or fatal medical conditions are due to abnormalities in these processes. Whether these anomalies arise from congenital disorders, acquired diseases, or trauma, we believe that a better understanding of stem cell biology will ultimately yield better medical intervention. So for more accurate diagnosis, we have to be thorough and be more effective, and stem cells are, of course, effective and for economical treatments also. And as of today in our time, let us just see what is the state of stem cell science in our day-to-day. So for the stem cell, since its first successful use in 1968, bone marrow transplantation has been applied to a variety of indications, ranging from leukemia to lymphoma to immune deficiency disorders, as well as to treat damage resulting from radiation treatment or chemotherapy. Patients appear to benefit from the infusion of blood stem cells found in the bone marrow. And today, umbilical cord blood rich in blood stem cells is being used experimentally as an alternative to bone marrow transplantation. When tissues and organs such as skin, blood, and liver are transplanted, stem cells within these tissues are believed to contribute to long-term regeneration of tissues and, of course, regenerating the organs in the process. And according to the International Society for Stem Cell Research, other stem cell treatments are still at a very early experimental stages and have not yet been shown to have a clear-cut advantage over existing therapies. And they are not considered a standard of care for any condition and do not have regulatory approval for the routine treatment of any disease. But despite the wide-ranging claims made by stem cell clinics on the internet, the successful portrayal of stem cell medicine is not yet substantiated by specific studies documented in peer-reviewed literatures. And according to the U.S. National Institutes of Health, which is the NIH, for stem cells to be made useful for transplant purposes, they must be reproducibly made to, number one, proliferate extensively and regenerate sufficient quantities of tissues. Number two, differentiate into the desired cell types or type. Number three, it has to have the ability to survive in the recipient after transplant. And number four, integrate into the surrounding tissue after transplant. Also, it has to have not to harm the recipient in any way and be able to function appropriately for the duration of the recipient's life. There is one research institute they called Stem Cells Incorporated has already achieved the first 5 imperatives on the list of the NIH list. The data with their pioneering clinical trials have shown the safety of stem cell transplantation. We hope, they say, to demonstrate efficacy as the work progresses. So only the continued research and time will tell whether the 6th item on the list comes to fruition, thereby fulfilling their mission to realize the potential of stem cells to transform medicine. And with that, knowing stem cells are going to be the future of the medicine and treatments, and hopefully eliminating a lot of the diseases that we have in our world today, meaning stem cells are cells that can have the potential to develop and be the treatment for all types of diseases in the body, depending on whether they are multipotent or pluripotent. So it, being the stem cells, they serve as a sort of repair system. To make it easier to understand, they have to be theoretically dividing without limit to replenish other cells for as long as the person or animal is still alive. So when a stem cell divides, each kind of daughter cell has the potential to either remain a stem cell or become another type of cell with a more specialized function. Let's say for a muscle cell or a red blood cell, or even become a brain cell. So these pluripotent stem cells can give rise to any type of cell in the body except those needed to support and develop a fetus in the womb. Stem cells that can give rise only a small number of different cell types are called multipotent. So where do these stem cells come from? Well, let's see, there are several sources of stem cells. The pluripotent stem cells can be isolated from human embryos that are few days old. And cells from these embryos can be used to create pluripotent stem cell lines. These are the cell cultures that can be grown indefinitely in the laboratory. And the pluripotent stem cell lines have also been developed from fetal tissue, which means these are the older tissues more than 8 weeks of development. And in late 2007, scientists have identified conditions that would allow some specialized adult human cells to be reprogrammed genetically to assume a stem cell-like state. These stem cells are called induced pluripotent stem cells, which is called also iPSC. iPSCs are adult cells that have been genetically reprogrammed to an embryonic stem cell-like state by being forced to express genes and factors important for maintaining the defining properties of the embryonic stem cells. So also, although these stem cells meet the defining criteria for pluripotent stem cells, it is not known if these iPSCs and embryonic stem cells differ in clinically significant ways. There are mouse iPSCs that were first reported in 2006, and human iPSCs were first reported in late 2007. The mouse iPSCs demonstrated important characteristics of pluripotent cells, including expressing stem cell markers. These are the ones that form tumor-containing cells from all 3 germ layers, and being able to contribute to many different tissues when injected into a mouse embryos at a very early stage in development. So human iPSCs also express stem cell markers and are capable of generating cells characteristics of all 3 germ layers. And although additional research is needed, iPSCs are already useful tools for drug development and modeling of diseases. And scientists are hopeful to use them in transplantation, medicine, and other treatments. Stem cell lines grown in the lab provide scientists with the opportunity to engineer these stem cells for use in transplantation or treatment of diseases. For example, before scientists can use any type of tissue, organ, or cell for transplantation, they must overcome attempts by a patient's immune system to reject the transplant. In the future, these scientists are hopeful that they may be able to modify human stem cell lines in the laboratory by using gene therapy or other techniques to overcome this immune rejection. Scientists might also be able to replace damaged genes or add new genes to stem cells in order to give them characteristics that can ultimately treat some diseases or most of the diseases that we are experiencing today. So let's talk about types of stem cells. There are some embryonic stem cells, which cells that are derived from the earliest stages of embryonic development and give rise to all of the different types of cells found throughout the organism as it grows and matures. They are therefore characterized as pluripotent. Pluripotent stem cells have the advantage that they can make any cell type. The downside only of this stem cell is that they can form tumors of mature cell types, which are called also teratomas, unless they are forced to become other specific stem or so-called progenitor cells. Then there are the tissue-derived stem cells, which are also referred to as adult stem cells or somatic stem cells. They are termed multipotent. These stem cells can produce all the functional cell types found within the tissue from which they are derived. For example, in mammals, the blood stem cells, or so-called hematopoietic stem cells, are responsible for the renewal or constant renewal of the various types of blood and immune system cells. In the brain stem cells are capable of becoming the neurons or glial cells comprising the central nervous system. The mesenchymal or the skeletal stem cells are able to form bone, cartilage, and the stromal cells are found in the bone marrow. The induced pluripotent stem cells or the iPS cells are differentiated cells that have been genetically reprogrammed to a pluripotent state resembling embryonic stem cells. While these cells meet the defining criteria for pluripotent stem cells, it is not yet fully known if or how iPS cells might behave differently from embryonic or tissue-derived stem cells when used as therapeutics. And then there are the progenitor cells, in which, in addition to stem cells, the scientists at Stem Cells Incorporated also did studies which are sometimes confused with stem cells. So these progenitor cells are more specialized than stem cells. They are early descendants of stem cells, and like stem cells, they can differentiate into more specialized cells comprising a specific organ. Unlike stem cells, progenitor cells cannot self-renew. And so we'll look closely at the stem cell as it goes into our daily lives, and hoping that one of these days we may have the definite answers to most of our problem diseases in our generation. So the therapeutic potential of stem cells, they have many degenerative diseases and disorders that are caused by the loss of normal cellular function in a particular organ. So when these cells are damaged or destroyed, they are no longer producing, metabolizing, or accurately regulating the many substances that are essential to life. There is no existing pharmaceutical product or other technology available today that can deliver these essential substances precisely to the sites of action under the appropriate physiological regulation in the correct quantity or for the duration required to cure the degenerative condition. Cells, however, do all of this naturally. Mature and functionally differentiated cells have lost the capacity for reproduction. Therefore, when such specialized cells are lost due to disease or damage, other mature cells cannot fill the gap. So stem cells, in contrast, are cells at an early stage of development, which have the ability to self-renew. That is, meaning to reproduce themselves, dividing into two cells, at least one of which is also a stem cell, for indefinite periods. They give rise to a number of different kinds of mature and functionally differentiated and specialized cells. So transplantation of cells or progenitor cells are already developed and but it also can still produce one or more mature cell types within the organ. And it may prevent the loss of or even generate new functional cells, which could lead to tissue and organ repair and potentially the restoration of a patient's health. And because of the self-renewal property of stem cells, a single transplantation treatment may have the potential to return an impaired organ to proper function for the life of the patient. This is the great promise of stem cells and the foundation of our therapeutic and developmental programs that is ongoing in our world today. So, what is the therapeutic vision for our stem cells in our world today? The vision is that the homologous transplantation of tissue-derived adult or non-embryonic stem cells is the most natural, biologically logical, and of course, therefore, the most promising and viable path to harnessing the therapeutic potential of stem cells as a one-time intervention that might effect a cure for many intractable human diseases today. And the therapeutic promise is to use the tissue-derived stem cells only in that same organ. For example, a homologous approach is, for example, to use a CNS-derived neural stem cells for the treatment of CNS disorders and liver-derived cells for the treatment of liver disorders. So these multipotent tissue-derived adult stem cells are naturally pre-programmed to become the mature and the functional cells of the organ in which they are found. So they are directly transplantable into the same type of organ. So conversely, these embryonic stem cells and induced pluripotent stem cells have the potential to differentiate into any of the various cell types of the body, and so they would need to be reprogrammed or genetically modified in order to reduce the risk of transplanting unwanted cell types. We have the allogenic transplantation, which these cells are the tissues or organs that may be donor-derived, or another one is autologous, which is also derived from the patient. These are our stem cells that are derived from healthy donors and ready for use and without modification, while those derived from patients may need to be genetically modified or corrected to eliminate the inherent disease or disorder. So, that being the case, we may have a very promising future for treatments of a lot of our diseases nowadays. And also, for our viewers' information, there are what they call scalable and bankable, which they also call stem cells in a bottle. These are kind of stem cells that are cryopreserved from donor-derived and can be reproduced at commercial scale, and so they call it stem cells in a bottle. And then they distribute it for patient doses as they need it, as they go along, which is much like an off-the-shelf pharmaceutical product. So stem cells that are derived directly from the patient that require a costly personalized implementation and one of safety protocol can be modified, grown, and expanded on an ad hoc basis, meaning as they need it, and it may not be practicable for timely therapeutic intervention. And so what are the ethical, problems ongoing with the stem cell research nowadays? Stem cells show a very, very good potential for many different areas of healthcare and medical research nowadays. And studying them can help us understand how they transform into the dazzling array of specialized cells that make us what we are. Some of the most serious medical conditions, such as cancer and birth defects, are caused by problems that occur somewhere in this process. So a better understanding of normal cell development will, of course, allow us to understand and perhaps correct the errors that cause these medical conditions. And research on one of a kind of stem cells, which is the human embryonic stem cells, has generated much interest and, of course, public debate. The pluripotent stem cells, in which these are the cells that can develop into many different cell types of the body, are isolated from human embryos, and these are the ones that are a few day old embryos. The pluripotent stem cell lines have also been developed from fetal tissue, which are older than 8 weeks of development. So, as science and technology continue to advance, so do ethical and viewpoints surrounding these developments. It is important for all of us to understand and explore the issues scientifically and ethically, because one day this may be the only problem solving for our healthcare problems in our world today. And so for more information for our viewers, there are following links to the internet site that are only offered for the convenience of the World Wide Web users. And you can log on to www.commissiononbioethics. And there are a lot of other things on there, in which one of them Commission for the Study of Bioethical Issues advises President Obama on bioethical issues that may emerge from advances in biomedicine and related areas of science and technology. Another one is the National Academy for Sciences Guidelines for Human Embryonic Stem Cell Research. And the National Academy of Sciences developed its first set of ethical standards for stem cells research in 2005. The guidelines were updated in 2007, 2008, and 2010. And then there's the Kennedy Institute of Ethics at Georgetown University, Library and Information Services, in which they allow searches of books, newspapers, journal articles, and other materials on bioethical issues. And then there's the ethics of human embryonic stem cells, research with the International Society for Stem Cell Research, and they provide this information as a public service to those wishing to discuss stem cell ethics. And also there's the Bioethics Advisory Committee in Singapore that addresses the ethical, the legal, and the social issues arising from biomedical science research. Also in Europe, there's a Eurostem Cell that has developed a fact sheet on the ethical issues around embryonic stem cell research. And we have an 800 number that our viewers can call us for all healthcare questions. And you can call us direct. It's an 800 number, 453-0438. Oh, and I would like to, and that's all, folks, for our presentation for today. That is just, enlightening all of us. For those who are interested in this topic, really, really interesting and, advanced and innovative topic about stem cells. And for all of you, thank you very much for gracing our show and watching us on FilipinoCentral.com. And I would like to thank International Nurses Association for giving me a really, really prestigious award. And it's very humbling and it's so exciting. So thank you very much. And again, for all our viewers, the phone line is open. If you have any questions regarding stem cells, we are online. We are here to answer your calls. I think we have a caller. Hello.
Hello, good evening.
Hi, good evening. Thank you for calling.
Yes, I was interested. I think I called the 1-800 number, so this is the number that I can call. So I'm definitely keep.
Okay.
Okay. I know it's kind of pricey, but I would like to know if my insurance will cover the cost or at least part of the cost of the procedure.
Can you repeat your question?
Okay. I know the procedure will be pricey. So
Okay.
I would like to know if I have insurance, is my insurance will going to be able to help me pay for the cost or at least the part of the cost?
Actually, for right now, the insurance companies are still debating on when to cover or what part of the treatment will be covered by them. A lot of times, these insurance companies are denying coverage for most of the stem cell treatments because for right now, it's still a very controversial issue for them. But we have some issues where they were able to get authorization and cover at least part or all of it if the patient really needed to be treated, after all of the other treatments are already exhausted, and let's say stem cell is the last resort or something, I think they consider.
Okay. Okay, now if you don't have any insurance, can you give me at least a brief price, cost that it will cost my family if we do that?
Yes, pretty much it's still pricey at this point in time because you know how it is. It's still they really are able to some research companies are able to perfect the processing of stem cells, but it costs a lot to do that. That's why they're also charging a lot. So for one treatment, I know some doctors who are charging anywhere from $5,000 to $20,000 for one treatment.
Okay, 5,000 for
But
likely like 5,000 per treatment, right?
yes,
Okay.
yes. But
Okay.
the outcomes are very, very promising.
Okay, that's a good news. And at last, I would like to congratulate you because you explained so much. It's so long process of explaining it, and I actually understand every single thing that you talk about the stem cell. So I really want to thank you for your trying, to explain to people what is important about it.
Well, thank you very much for calling, and thank you very much. I hope you like our show, and I hope we were able to help out a little bit.
Yes, thank you so much. I've been looking forward for more shows.
Thank you
Let's look
very
forward
much.
to see you.
Thank you.
Okay,
Thank
Han.
you.
Okay,
God
bye-bye.
bless. Bye bye. Good night.
Good night.
There you go, folks. If there are more callers, our phone lines are still open. We're still probably here for the next 10 minutes, and I hope you enjoy the show. For the meantime, we're going to still show you some of the video clips about the opinions of some people regarding stem cells. And this is in LA. And remember, we are still live direct from the FilipinoCentral.com. Thank you for calling Focal Point. This is Lourdes.
Hello.
Yes, good evening. This is Lourdes. How can I help you?
Hi, Lourdes. My name is Rick.
Hi, Rick.
I have a question about stem cell therapy for Parkinson's disease. I have a relative who has Parkinson's.
Okay, yes.
Is there currently any clinical trials that they're performing with stem cell research for Parkinson's?
Oh, yes, there are a lot of clinical trials going on right now, not only for Parkinson's disease, but for all other kinds of diseases like macular degeneration. There's some for stroke victims, and there's a lot of other things, especially also, of course, for Parkinson's disease. And there is a database from the NIH, National Institute of Health, and they sponsor some clinical trials, and you can go to www.clinicaltrials.gov, and you can enter the search items of your interest. And in this case, of course, you can go to Parkinson's clinical trials about stem cells to search for your trial. Okay?
Is there any ethical issues anymore with stem cells regarding, you know, they used to take them from embryos, but now it's all completely done through
Yes. Yes, the human embryonic stem cells are still very controversial as of this point. So we know President Obama a few years ago, he stopped the research on that one. But nowadays, they are using the patient's own stem cells. So what it is, they harvest the stem cells from the bone marrow and re-inject it into the patient, and or they get it from the amniotic fluids, which is they say is safer and more effective. So yeah, that is like going away from the embryonic stem cells, controversy.
Okay. Yeah, I hear about these parents, I guess, the well-to-do people that go and they actually will bank their child's umbilical cord
Yes.
stem cells.
Yes.
So they're used.
Yes. They do the banking right now, that what they plan to do is to bank this comes from the umbilical cord. So they bank that, and like in the future, if they need that, they can request for that, and then those people who banked it will process and give it to them, and we inject it to whoever is compatible with the stem cells from the umbilical cord. But the banking, I think, costs a lot.
Yeah.
Yeah, I don't know how much, but I know the payment is on a yearly basis.
Uh-huh.
Yes.
Okay, well, thank you for your answers, and thank you for your time.
Thank you very much, Rick. God bless you, and good night.
Good night.
Thank you. And there you go, folks, for our show for tonight. Thank you very much for watching our show, and thank you very much for the callers. Hopefully, we're able to help you out a little bit regarding this issue, and hopefully on our future shows, we'll be able to help more people with their questions, and we'll be able to answer them. Thank you.